Hey, good evening, my warriors. Welcome to the first session of capacitors. Now, many of you might not have even seen a capacitor. Well, that's the one which I'm holding in my hand, which you can see on the screen. That's how a capacitor looks like. It's very tiny. It's not as big as it's shown. It's just so that you can see it clearly. Now, you might be wondering, where do you actually use the capacitors? Well, believe me, when you want to store a lot of energy and you want to discharge it in a very small amount of time, that's when you might use a capacitor, just like the flash of a camera. So, a lot of energy which comes out in burst, that's where the capacitor releases all its energy. And then also defibrillators, where you might have seen in movies where a person is about to slip into coma or about to lose his consciousness, and then they use the shock therapy. A lot of charges pass through the body and the body probably regains back the consciousness. So that's again a very good application of capacitors. So we'll study more in detail with me, Shreyas, your master teacher for physics at Vedantu going live. Hello, Lakshya Prasadam. Yes, this is enough for clearing JEE Mains and Advanced. We are a JEE English channel, both for mains as well as advanced. Nice to know, Ankit, you're watching it live from your PC. Most likely, I guess you can watch it on your tablets or maybe your phones. Good evening, Deborah. Hi, Jai Krishna. Hi, Nancy. Hi, Kumar. Welcome aboard, Samuel. There is no session of me in the crash course. Why? Because I cannot be there everywhere. First of all, let me tell you where and all I am there. I'm already teaching, the 12th standard. Then I'm already, in many of the micro courses, I'll be sharing the link very soon. I'll tell you where. Also, I'm teaching on Enthuse, and then we have also decided to teach on catalysis. So guys, I'm already there at so many places. Plus, I'm managing the physics department. So trust me, I cannot be there everywhere. But all the Vedantu master teachers are amazing, awesome. So you don't have to really worry about it. Just have blind faith, just take a leap and you will see that you will excel. Okay, just trust your teachers. Hi Ojasvi, hello Srinidhi. Hi Avdesh, yeah, back. You're back. Well, you're 11th standard, but this is a 12th standard topic. I'm not sure how much of it you will get, but it's okay, fine. Hi Bhavya, good evening. Hi Gaurav, Yalini, Vanakkam. Hello Jayavant, hello Gaurav, welcome aboard. Nice to see all of you guys out here. So guys, I have been training kids for a very long time and I want to do so, and I really want you guys to get into IITs, NITs and you name it. And by the way, if you want to know more about me, just follow me on my Instagram handle, that's Shreyas_Vedantu. Alright, so let's begin with our session. But before that, let me show you the schedule for this week. Just 1 second, let me set the lights right out here. Yep, just 1 second. Okay, so this is the schedule, guys, for this week. Now you can see clearly that I am starting off with capacitors. Then tomorrow morning, a new series launch for all the 2021 students. It's called as the Rank Booster series. We are already done the Zero to Hero series. There are more than 20 sessions on Zero to Hero just in physics. So ace your performance, boost your performance. This is like your second dose of vaccine. Alright, that's a booster shot that you're going to get in this series. We're starting off with kinematics projectile, and then this is for the 11th standard kids, instantaneous velocity, acceleration, derivatives, graphical, and then we'll go to the analytical, the formula methods on Friday. Okay, so that's on Friday. Guys, this should have been 7:30. This is not 5:30. I will get it corrected, don't worry. Okay, that's 7:30. Then the second lesson of capacitors is going to be on Thursday. This is also at 7:30. It's not 5:30. Please ignore that. And special session on Saturday for all of you. And one more special session for you on Wednesday. A lot of you kids were asking, sir, where are your micro courses? Where are the links? Sir, which courses do you teach? I'm going to talk all about it in this detailed small session. It's not a big session, it might be just for 15-20 minutes, but this is very important. All my courses revealed and how you can make the best use of these courses. All of it on Wednesday. Alright, so be there guys. All these sessions are for all the students, be 2021, 2022, 23. I've mentioned it all out here. By the way, Vedantu has also taken up this initiative of pledging support to all those kids who have, probably been troubled by this pandemic out there. So guys, we have launched the Help India initiative, and that's by Vedantu. So you can know more about it by checking out the link which is there in the description box. This is something where you should also contribute. We are also contributing in our own ways, and I feel that this pandemic has affected a lot of kids out there. So guys, it's a very good initiative, very noble initiative. So I hope you guys will participate in this, and know that if you are already in Vedantu, your chances of getting into IIT, NIT, IIIT, BITSAT has almost increased 5 to 6 times. Look at these results. I mean, a student who studies elsewhere, the chances of getting him, all right, into an IIT is 1.25%. That's the ratio average. But inside Vedantu, that's around 6.6 times higher, which is around 8.25%. Number of students actually get inside IIT. That's a very big deal, and a lot more students get into NITs and other top-notch colleges apart from IITs. In fact, 1 in 2 Vedantu students have already qualified for JEE Advanced. And guys, if you want to take the best use of this, please join our courses, and all the links, be it the crash course for 2021, be it the long-term batches for 2022, or even the 11th standard students, also we have the 2023 batch, and all of these details are there in the description box. You can hit the link where the batches are starting every now and then. The more you delay, the more you will be completing the portion later on. So earlier start, the better it is, and you can get a lot of discount if you use the coupon code SHHPRO, and if you want the crash course, then it's SHHCC. All right, and you can take 1 month, you can take 12 months, it's up to you, and there are different versions. You will know more about it later on. All right, so Gaurav, yes, nice to know all of this. Hi Kusuma Bhargavi, welcome aboard. Yes Nisha, let's start, why not? Very good Abhi, that's very good to know that you guys are going to contribute as well. Hi Jay Surya, nice to see you out here. Okay, well Avdesh, guess what, I'm going to make a video on that too. How do you crack using all the online resources that you have? So I'm going to make a video on that. What is crash course? Crash course is for all the 2021 students who want to complete the portions and give the test series, and they want the assignments, materials for practice in the last few months. The exam is going to be in July or August most likely, so it's for them. Good evening everyone. So now I have a question for all of you, and the question is, hi Pari, good evening. Yes, Dharmarajan, it's already over. You can check it out in the playlist. Okay, so what will happen if you take 2 charged bodies? They are 2 charged conductors, and one of them is positively charged, the other one is negatively charged. So don't you think there will be some field which will be going from the positive to the negative? If there is field lines which go from the positive to the negative charges, okay, because these are positive, this is negative, there will be electric field lines which go from positive to the negative. Remember, field always goes from high potential to a low potential. That's the rule of the field lines. That means there is some potential difference. I can say there is some potential difference, okay, there is some potential difference between the conductors. Yes, there is some potential difference. 2 volts, 10 volts, 20 volts, I do not know, but there is some voltage difference between the conductors for sure. Now, if you have understood it till here, what if I actually connect some device? It could be a motor, it could be a bulb, it could be anything between these 2 conductors, something like this. What do you think will happen? Let me know in the chat box. What do you think is going to happen? Come on, guys. Yo, thank you, Chaitanya. Yes, guys, in case you have forgotten to smash the like button, please do so and show your support out there by smashing the like button. And if you are new to the channel, do not forget to hit the subscribe button. It's all for free, and you show your support, show your love by doing so. Okay, says Clearo, the bulb will light up. But what do you think, Deborah? Will the bulb light for a long time, small time? What will happen? Well, obviously the bulb will glow. Yes. Why? Because the charges will flow from higher voltage to lower voltage. The current will flow from high potential to low potential. And once the current flows between them, the bulb will glow because current is flowing inside the bulb. That's what will happen. So the energy which was stored was earlier in the form of electrostatic potential energy. So these conductors just some time back had electrical potential energy, and then that electrical energy was converted into other forms like light, heat, which was used by bulb to glow itself. But obviously the energy stored is not infinite. It is a small finite quantity. So as the current flows, the charges will move and they will neutralize the negative charges, and eventually no charge will be left and the bulb will turn off. So don't you see this is a momentary phenomena? Exactly, Kumar, their potentials will be equal. That's when the flow of the current will stop. So this device, these two red conductors, is nothing but an energy storing device, and it supplies that energy till both the conductors are at the same potential. All right, one is at high, one is at low, their potentials become equal, there is no more flow of current. That kind of device is nothing but a capacitor. So you can see that after some time all the energy gets utilized and the bulb will turn off. Everybody clear? Yep, everybody clear? Let me know about this. Yes, it is going to be a small time. So this is how a flash works. So there is a capacitor. Okay, so this is actually a very crude way of showing that this is a capacitor. And there is a capacitor, this is your flash bulb, sudden gush of charges. The charges are so excited, they're like, hey, we have to go to lower potential. They'll all rush through the wires, through the bulb will glow momentarily, the potentials will become equal, the bulb will stop glowing. It's a momentary flash, some circuit will come and it will go off. That's it. That's how it is. Okay, so what is a capacitor? So capacitor is nothing but an energy storing device, but in which form? Electrical energy. Yes, it stores electrical energy in that electric field which is there around it. You just saw that. There was positive, there was negative, there was field coming from positive to negative. So that's where it stored the electrical energy. So that's what a capacitor is. Please make notes, because if you don't make notes, then most likely you will just forget whatever we learned today. So it's very important that you keep making notes as we discuss all of this. Short notes, shorthand, that's all. Okay. And this energy, like I said, is temporary, and the potential difference will drop, and once the energy is utilized, that's it, there is no more supply of energy. You might ask, sir, what's the difference between a capacitor and a battery? What's the difference between capacitor and battery? Yes. Do you know what's the difference? Well, here's the difference. When you use the energy from a capacitor, the potential difference gradually reduces and the potential difference becomes zero. The difference slowly becomes zero. But in a battery, no. If you use a 5 volt battery, it will remain 5 volts even after a long time. It continuously maintains that potential difference. And it's not a sudden discharge of all the charges. It's not like when you use a battery, all the charges come out within 1 second and that's it, it's gone. The battery is useless. No, it's not like that. It takes a long time to discharge a battery. Understand that. Okay? I hope everybody is clear about this. So GDB Joker, you can do one thing. You can just take the slider below on the YouTube, just slide it behind and watch the replay at 2x speed as well. That's the best part about watching on YouTube. Okay, so yes, Abhinav, please use that. Definitely. Yes, use that. Okay, let's get going to the next concept. So capacitor is nothing but energy storing device. There is potential difference, current flows from high to low potential. During that flow, the bulb glows or any device will work. As soon as the charges are neutralized or the potentials are equal, there is no more flow, and that's it. You have utilized that energy in that device, and the capacitor is said to be discharged. The capacitor is said to be discharged. Earlier, the capacitor was charged with electrical potential energy. Okay. Yes, Jayavant, we are going to study all of that now. We are going to study all of that. In fact, there is a special lecture on just charging and discharging and finding the equations related to charging and discharging. Just a special lecture for that. When should you use a capacitor? When you want sudden discharge of charge, Ankit. And there are other uses also. You will learn about the other uses in AC circuits, where you will learn how to use a capacitor as a filter and LC oscillations and transmitter and receiving circuits as well. You will see that. Yep. Okay. So where would you place the bulb or the load on in a capacitive circuit, says Jagdish. So Jagdish, you will just connect it in parallel or in series. So just have a capacitor, so connect one terminal to one end of the bulb, the other terminal to the other end of the bulb. That's it. The capacitor will give away all its charge slowly to the bulb and it will glow momentarily. Okay, I hope all these things are very clear. Now look at this. These are two conductors. One is having plus Q charge, one is having negative Q charge. So what has exactly happened? Earlier, remember this, before what happened was both the conductors had no charge on them. They had no charge on them. They were discharged. So what you did is you took away Q charge. You took Q charge and put it over here. You took how much charge? Q charge. If you take away Q charge plus Q charge, how much will be the charge on this conductor? Negative Q. And since you have taken plus Q and put it over here, this conductor will become plus Q charge. So what you have done is basically taken a charge plus Q and put it on the other side. So you have done some work, and obviously there is going to be some potential difference. What is this V? This is nothing but the potential. Alright, this is nothing but the potential difference. Keep this in mind. This is the potential difference which is created between these two conductors. Guys, remember, I might not be able to answer all your doubts in the live class, but if any doubt remains, you can ask me on my Instagram handle, which is there, Shreyas_Vedantu, number 1. Number 2, I reply to all the comments which you post after the video ends in the comment section. Right now it's not open, but later on after the video ends. Okay? Harsh, you can do that. Bodhasigni, it's starting tomorrow. I have already mentioned the timetable at the start of the class. Now, if this much is clear, it is found that the charge that you store is directly proportional to the voltage. If you store more charge here, then the voltage will increase. Why? Because if the charge is more, the field will be strong. If the field is strong, the voltage difference will be more. Understand that. So the charge which is stored, okay, so this is the charge stored on the capacitor, okay, is directly proportional to the potential difference. Exactly proportional to that. More voltage difference, more charge stored. So the value of Q is, replace this proportionality with a constant. That constant is C. This is the voltage difference. This becomes a very important equation. This constant of proportionality itself is called as the capacitance. This is called as the capacitance. Very, very important. No, Jayasuriya, I have mentioned about flux and field lines in the previous chapter, previous actually, in electrostatics. So what's that lecture? They are completely different things. Flux is the flow of field lines. Okay, they are different things. Okay, so what is the unit of capacitance? Guys, you can see, if I take 1 coulomb of charge, okay, if I'm able to store 1 coulomb of charge for 1 volt of difference, then the capacitance is said to be 1 farad. What is 1 farad capacitance? If you are able to store 1 coulomb of charge for a voltage difference of 1 volt. Now that's a huge capacitance, because 1 coulomb itself is a very heavy, huge amount of charge. So generally the capacitances are not this much, they are very less. 1 farad is a big unit. So what did we see? So if Q is the magnitude of the charge stored, V is the voltage difference, then the value of the charge, where is it? Is it not coming? Okay, come on. Okay, I'm not sure what happened. Just 1 second, guys. Maybe some technical difficulty out here. Okay, there we go. So Q is proportional to V, and because of that I can have a constant of proportionality that is called as C, which is nothing but the capacitance. So the capacitance of a capacitor, like I mentioned, is 1 farad when 1 volt of voltage difference stores 1 coulomb of charge. Is that clear, everyone? What is capacitance? Capacitance is exactly this: how much charge you store per voltage, per unit voltage. You can see C is Q by V. So how much charge you store per unit voltage, that's nothing but the capacitance of a capacitor. I hope this is clear. Okay. So Piyush, you can mention all your doubts after the class is over, or ping me on my Instagram handle, which is there in the bottom. So I'll definitely help you out with your query. Don't spam out here. Okay, cool. Let's get going to the next one. Okay. Now, what is the symbol of a capacitor? It's nothing but just 2 lines. Just 2 lines. Yeah, just show 2 lines and just show terminals. That's nothing but the symbol of a capacitor. Okay. Some books also use this as the symbol. Okay, that is also a symbol of capacitor. 1 curved line and 1 straight line, one and the same thing, guys. Generally the capacitance is in micro or picofarad. Okay, very small. You will not get in megafarads, kilofarads. That's ridiculously large amount of capacitance. Okay, that's what capacitance's general ranges are: microfarads, millifarads, picofarads and all that. Now, what does the capacitance depend on? A lot of people make mistake over here. Okay, it depends on how you actually make that capacitor, what you actually put inside that capacitor, and we are going to discuss all those factors affecting capacitance in detail after some time. But for now, remember, it depends on the dielectric. Do you remember dielectric? I have talked about dielectric constant K in electrostatic, how it reduces field K times. Epsilon naught was the permittivity of free space. When you multiply it with that constant K, which is unique for every material around you, so that gives you the new permittivity of the medium. It gives you the new permittivity of the medium. No, it's not a battery, Varad. It behaves like a temporary battery, like a battery which stores energy for a small time and gives out all that energy. That's how a capacitor behaves. Well, okay. It depends between the dielectric, what you fill inside that capacitor. Okay, it also depends on the size and what type of capacitor it is. Yeah, it will depend on how big, how small, what is the distance, etc. between the conductors. So it depends on all these factors. Yeah. Okay, let's get going. Vijay Kumar, no, we are not going to complete before September for sure. Okay, we are going to go much beyond that. I'm taking it slow and steady because I want you guys to understand we have started this long-term series just for you so that you can get the best out of all the 12th standard, 11th standard portions. And by the way, since the examination has already been postponed for all the 12th standard students, I'm pretty sure next year's academic cycle is also slightly shifted. So definitely your lap for this 12th standard is going to be a little bit longer than usual. Let's see whether you can solve this question out here. For a capacitor, if the voltage is increased, which of the following will be increased? Come on, which of the following will be increased? 1 or more than 1 may be correct. I'm not sure. Think about it. Jayavant, capacitor is not used to decrease the potential difference. When you use a capacitor, it automatically decreases. Jagdish, nobody can guess so accurately, but my guess is July end or August. Okay, some of you are saying AC, some of you are saying B, some of you are saying A and D. Well, a lot of you are confused for sure. Come on, read the question very carefully on your screens. What do you think is the correct answer? What will happen if if the voltage is increased? What do you think will happen? Well, guys, use this formula. Q is equal to CV. Okay, just use this formula. Q is equal to CV. If voltage increases, what will happen to the capacitance? Nothing. Why? Because this guy does not depend on V and Q. It depends on the material, it depends on the size and the geometry. So, for a given capacitor, when you increase the voltage, the capacitance does not increase. It's only that the charge will increase because it is directly proportional. More voltage, more charge. Less voltage, less charge. Do not think capacitance will change. That's a completely wrong idea. A lot of people do not get it at the first go. But remember, capacitance depends on the material, the type, the geometry, the sizes of the conductors which are storing those charges. So hence the answer is only option A. A lot of you got it wrong, guys. Yeah, a lot of you got it wrong. I hope the next question you will be able to do it correctly. It's going to get slightly more tougher. What do you think will be the correct configuration of the charges on the capacitor? So you have the two charges, you have the two conductors. Let's say they are both plates. You put plus Q charge here, you put minus Q charge here. How do you think they will distribute themselves, okay, in a capacitor? So these are the two plates. Which of the following is the correct configuration? Only one of them is correct. Think about it. Okay. Wow, very good, Vijay Kumar. Yes, in fact, not 2 chapters, Vijay Kumar, we have completed 3 chapters. Electrostatics, Gauss's law and current electricity. This is the 4th chapter of Pathfinder. Guess what? Yes, we have already reached the 4th chapter. Okay. Keshav, why don't you post a comment after the video ends? I'll definitely help you, or ping me on my Instagram handle, which is Shreyas_Vedantu. Definitely I will reply to you. I reply to everyone. Okay. So a lot of you are saying D. Some of you are saying C also. One of you said B. Well, guys, remember plate problems? I have done an exclusive lecture on just plate problems. Just the problems on plate. Yes. And I had told you, whenever you have 2 plates and this plate is given Q charge, this plate is given minus Q charge, I had given you one trick. What was the trick? Add the charges on the plates. If you add both the charges, Q and minus Q, what is the total charge? What is the total charge? Q and minus Q, 0. And then divided by 2. Remember, divided by 2. I had given you all this. So the total charge divided by 2 will be 0. Where does the total charge divided by 2 come? It will come on the outermost surfaces. It will come on the outermost surfaces. So the outermost surfaces should have 0 charge. Now there is only one option like that. You can see there is 0 charge here, there is 0 charge here. Both of them are basically the outermost surfaces. That's the trick I had given you in the plate problems lecture, one lecture exclusively just for plate and shells in the Pathfinder series. Lastly, obviously I have given Q charge, so that charge has to be there somewhere. Where will it be there? Obviously on the inner side. So these 2 charges will be there on the inner surfaces of the capacitor. So whenever you have a capacitor, remember one thing, the outermost charges are 0, the charge Q is stored on the inner or opposite faces which are facing each other, and the field will be there in between them. Understand? So this is where the field will be inside, no field will be there outside. So outside there is no field, inside there is field. Okay, outermost charges are 0. Everybody clear about this? I'm pretty sure a lot of your concepts have got cleared now. Okay, a lot of you would have thought either this, or you would have thought, oh no, it's outside. Oh, I thought it was distributed. Or some of you would have never thought about where the charges are stored in the capacitor. No problem, Surya. Just finish it fast. Make sure you catch up and cover up all your backlogs out there. So the correct answer is option D. Let's solve the next question. This is a beautiful question. Let's see how many of you can do this. So there is a capacitor and you have connected it to a battery, and what you do, you remove that battery and flip the battery and reverse it and connect it back again. So when you have that battery originally, the capacitor will get charged, and you remove the battery, I think the charges will still stay there. Reverse it, connect it. New charges will develop on the capacitor. So I feel some charges will flow. How much charge will flow through the battery? That's the question. Let's see how many of you can do this. It's not that difficult. Come on. Thank you, Sriniti Selvan. Thank you so much. And continue doing so. Keep learning. And yes, please have fun when you watch these lectures. I'm pretty sure you'll get inspired to crack JEE. Shyam says C, Ankit says B, Anushruti says C. Okay. Kodwar also says C. GDB Joker saying A. Ankit's shifting to B. Oh, Ankit already said B. I'm not sure. Okay, come on. All my other warriors, think very closely. What's the answer going to be? Punamri saying D, Patel saying C. You have reversed it. Okay, let's think what will happen. Okay, first, when the battery was not like this, when the battery was, let's say, like this, this was earlier, or yeah, this was earlier. Okay, this is when the battery was actually like this. This was the positive side, this was the negative side, this was the voltage of the battery. So what will happen? This side will have plus Q charge, this side will have minus Q charge. Isn't that right? So positive to positive, negative to negative. Obviously the positive side will have positive charge, the negative, the lower potential will have the lower charge, the negative charge. What is the value of this Q? This Q will be capacitance, which is C, into voltage difference. What's the voltage difference across the capacitor? Same as the battery's voltage, which is V. Same as the battery's voltage, which is nothing but V. Is that clear? Now, what have you done? You removed this battery and you flipped it. Yes, you have flipped it. Now in the new scenario, what has happened? Your battery is like this. This is positive, this is negative. So these charges will also flip. This will become plus Q, this will become minus Q. These are the new charges. Remember, these are the new charges, these were the old charges. So guys, think about it. If you look at any plate out here, just look at any plate. Earlier, it had negative Q charge. Now it has plus Q charge. That means on this plate out here, which had negative charge before, what have you done to make it have plus Q charge? Earlier it had negative Q charge. What have you done to make it plus Q? I think you have added, you have taken it out from here. How much charge have you taken? Exactly, you have taken 2Q charge, guys. Minus Q plus 2Q is Q. It's not zero. A lot of you think, oh sir, minus Q plus Q, zero. No, signs. Come on. Where are you? Basic maths, algebra. This is probably a 5th standard, 6th standard question. From minus Q to plus Q, what's the change? It's 2Q. So guys, the charge which has flown, is 2Q, but Q itself is CV, so it is 2CV. So hence D is the answer. I think none of the warriors, or I saw majority of the warriors got it wrong. Majority of you got it wrong. So guys, do you understand? Yes, Surya, the answers are always put in the PDF as well. So do you guys understand? Capacitors is a very conceptual chapter, and if you miss out all the lectures, miss out all these questions, you're going to miss a lot and you are going to suffer, and then you'll be like, sir, I ignored capacitor, I did not study capacitor, please help me out, and you will ask me all of this towards the end of the year. So please make sure you study this chapter in detail. This is very important. Okay, yes, so 2CV. Ankit, 2Q, right? What is Q? Q is CV. Earlier the charges were minus CV plus CV. Now the charges are plus CV minus CV. So from minus CV you have gone to plus CV. Minus to plus. So what is the change? 2CV. I hope this is clear, Shyam and Ankit and others. Is that now clear? Earlier it was minus CV, now it has gone to plus CV. So change is 2CV. So you have taken how much charge? You have taken 2CV charge from here and put it here. I hope now it's clear. Is that okay, Shyam? Yeah. Sir, can put in step methods. Yes, Surya, you can take a screenshot, you can watch the replay, you can pause the video later on whenever you want to solve the questions, yeah, or you want to see the solutions for these things. Okay, so having said that, let's move ahead. Yep, the answer, I don't know why the board is not working today. Yep, okay, fine. Now, let's see the 3 types of capacitors. This is very important. This is going to be very crucial. A lot of questions come from them. Exactly, Alni. Okay, come on, think about it. If I tell you the charge before was minus CV, now this was before, okay, this was before. Now the charge is plus 3 CV. How much charge has flown? how much charge has flown? Come on guys, answer this. This should be very easy. Yes, Shyam, whatever charge will go through the battery only, right? Remember, this is the capacitor. It is taken from here. All right, it is taken from here. It will go through the battery. It will go through the battery and it is put over here. That's why that minus becomes plus and this plus becomes minus. I hope that is clear. Exactly, minus CV to plus 3V. The charge flown is nothing but 4 CV. That's it. I hope now you guys get it. Beautiful. Shyam, I hope you understood. So the charge which changed on this plate has to come via the battery. There is no other path, bacha. Okay, great. I think you guys are getting it now. Okay, now all the different types of capacitors out there. Number one, parallel plate. Number 2, cylindrical. Number 3, you have spherical type. Yes, number 3, you have spherical type, and a special case in that, which is the isolated type of spherical capacitor. Yes, isolated type of spherical capacitor. Okay, great. Now, let's see all of this one by one. The first thing, what is a parallel plate capacitor? It's nothing but two plates. Okay, you take two conducting plates, connect it across a battery. You will see, because of that battery, positive charge will come on one plate, negative charge will come on the other plate. And because there are different polarities, there will be field lines which go from positive side to the negative side. So there is field. Okay. Now we will figure out how much this field is, because questions do come in the JEE examination. What is the field? What is the force? And what is the capacitance and all of that? So let's figure this out step by step. Okay. Observe this. Because this is positive, this is negative. Well. The field lines will go like this. This is how the field lines will go. Now, my question to you guys is this. Because of this positive charge, it's a plate, right? At the end of the day, there will be fields in both the directions, right? There will be field in both the directions. One will be outwards like this and one will be again outwards like this, away from it. This is the field because of this positively charged plate. Guys, do you remember the formula for the field due to a charged plate? Field due to a charged sheet? It was sigma by 2 epsilon naught. Excellent ABCD, very good. You already wrote it. Sigma by 2 epsilon naught. But what is sigma? Sigma is the charge on the plate per unit area. The charge per unit area is the surface charge density. So it will be nothing but Q by A, and there will be 2 epsilon naught over here. So the field from this plate is going both ways, and the magnitude is Q by A into 2 epsilon naught. Great. Yes. Now, similarly think the bottom plate out here. Okay, the bottom plate out here will also create some field. Yes, this negative charge will also create some field, and because it is negative, it will be attractive, it will be pulling it inwards. So the field will be like this. This will be the field. And how much will be this magnitude? Again, sigma by 2 epsilon naught, but sigma is charged by A, so it will be Q by A and 2 epsilon naught. This is inwards. Now, I want you to think about this. Understand, these blue lines will continue even here. It's not like it's going to end. It's going to continue here too. And even this red line, well, even this red line will continue even over here. Let's just observe this carefully. If you are outside, either this way or this way, if you are here or if you are here, above this plate or below this plate, don't you see the field lines cancel each other? Don't you see the field, the red field line and the blue field line cancel, because magnitude wise they are same, directions wise they are opposite. So can I say the field outside is 0 because the field which is down will cancel with the field which is up. They cancel. Everybody clear about this? Hello Yash, welcome to the channel, the JEE Enthuse English channel out here. Next up, if you are inside the field, between the plates, do you think they cancel out or do they add? Let me know in the chat box. Do you think these field lines in between these two plates, will they cancel or will they add up? Exactly, think about it. It's going to add up. Beautiful, it's going to add up. And what will be the answer? It will be Q by 2A epsilon naught. Alright, the red one plus, yes, the blue one, which is again Q by 2A epsilon naught. So what are you going to get? Half and half is 1, guys. So hence the net field in between, alright, is just going to be Q by A epsilon naught. Now this is something which you are supposed to remember. The field between the plates of a capacitor is sigma by epsilon naught or Q by A epsilon naught. Very, very important formula. Beautiful. A lot of you got it. Excellent, guys. I'm really proud of you. Shall we go ahead? Yes. Don't worry. All these things will be given to you even in the notes out there. Yes. Even in the notes out there, you're going to get it. Okay. And if you want to replay this part, you can definitely do so later on. Okay. You can take screenshots. You can do replay. You can pause the video even after the video ends. Now, once I know the field, I can also figure out what's the capacitance. Yes, I can figure out what's the capacitance. I'll tell you how. Guys, we just figured out, the field between the plates is Q by A epsilon naught from the previous slide. Okay, from the previous slide, we just figured out field between the plates is Q by A epsilon naught. Do I know some formula which relates field and potential? Why would I need such a formula? I'll tell you in a bit, but just think, is there a formula which relates field and potential? I think we know that. Field, alright, field magnitude wise, we're just interested in the magnitude, is delta V by delta R. Do you remember this? Delta V, dV by dr, excellent. But this E, if it is uniform, why is it uniform? You can see this is a constant value. They are parallel lines. It's a uniform field. So guys, just substitute everything out here. E's value is Q by A epsilon naught. I don't have to do derivatives or integration because it's uniform field. So what's the voltage difference? Well, that's V. What's delta R? That's the distance between the two plates. Voltage difference between the two plates? Delta R, distance between the two plates, which is D. Rearrange this. You are going to get Q is equal to epsilon naught. Okay, you're going to get epsilon naught A by D into V. You're going to get this. Now, just some time back, didn't I tell you Q is equal to CV? Didn't I just tell you some time back Q is equal to CV? Look at this expression. Q is equal to something into V. Q is equal to something into V. That means, guys, what does this tell you? C is equal to epsilon naught A divided by D. That's the capacitance of a parallel plate capacitor. That's the capacitance of a parallel plate capacitor. That's it. That's it. And hold on, there is a bigger surprise. If you do not like this, I can even write it even better, epsilon naught A by D. This is when there is nothing inside it. Yes, there is nothing inside it. But if you fill some masala, it's like a sandwich, you add some cucumber, you add some tomatoes, you add some sauces. It will be yummy, right? And in that case, basically what I'm talking about is dielectric. In that case of dielectric, this epsilon naught should be multiplied with K and multiplied by A, and this is D. So this is the final formula. So what is this K, guys? This K is nothing but the dielectric. This is the dielectric of that masala that you are going to add. Yes, it's the dielectric of that masala that you're going to add. It will increase K times. Excellent. Very good, very good, very good, Yalini, very good, Ankit, very good, Anushrut. Excellent ABCD. The dark, I have already made a video on that, most likely July or August. Yep. Yeah. So, do you see capacitance depends on material? That means masala. I just gave you that some time back. It depends on the geometry, the size. A, D depends on the sizes, geometry, and the masala in between. That's how it is. Okay, very good, excellent. Let's solve some questions based on this. I hope you have written it down. And by the way, all of this will be there in your PDF. So if you're wondering where you're going to get the PDF, well, you just need to join our Telegram channel. You're going to get the entire PDF. You're going to get the updates. You're going to get the notifications and my beautiful voice notes out there. So go ahead, join the Telegram group. The link is there in the description box below. So let's start with a question coming up on your screen. I hope you have made notes. I hope you have written down the formulas. Now more than one may be correct. In which of the following will the capacitance increase? In which? Yes, it will depend on the medium between the plates, Ayush. That's called as the dielectric constant. Masala is something what you fill. Surya, I'm pretty sure all your curries, all your vegetables have a lot of masala in it. Surya, yep. Dark, don't spam. We are not going to answer all the spammers out here. Okay. So, what do you think the answer is? ABCD says ADE. Yalini says ADE. PSK says AD. Ankit says only E. Guys, more than one may be correct. Aarti says E. Nice profile picture, Aarti. Okay. Nancy says ADE. Srivatsan says ADE. Okay. Well. Guys, what was the formula? Yep. Most of you are correct. Very good, my warriors. Excellent. I'm really proud of you. Capacitance is epsilon naught K A divided by D. Capacitance should be increased. So you want to make this higher. What can you do? You can make K higher, A higher, or the denominator lower. So area is increased. Yes. Distance between the plates is decreased. Yes, the denominator decreases, the ratio increases. Material is inserted. So if you add some masala, some K, it will increase K times. Yep, that's how it is. Beautiful, guys. Next question coming up on your screen. Read it. Yep, please read it. It's a big question, but it's not so difficult. What is happening? I'll spare you the reading out here. There is a charge and you throw it exactly in between the plates of a capacitor. The distance between the plates is, let's say, D, area is A and all that. And there is some field between the plates of the capacitor. Now, what is happening is that this charge will go in a curved path because it will experience a force. Remember, electric field means electric force. So the charge will get deflected and it just misses the edge of the plate. It starts from here and it misses the edge of the plate. So the question is, what's the time? What's the time of flight of the electron from this point to this point? Yep, correct, Ayush. Yes, Ankit, we will be doing mock tests once we have some clarity. For now, rank boosters for all the JEE. Okay. So now, guys, do you agree that the force on the electron will be the charge multiplied by the field? Charge multiplied by field. What is the charge of an electron? Charge of an electron, E. What is the field? Well, that's going to be E. Is this not a constant value? Come on, guys, let me know in the chat box. Do you guys agree with that? Yes, it's a constant value. Very good. Manthrini Style, this is actually 11th, 12th channel, but if you're in 10th, then you might have to wait one more year before you start seeing our 11th standard videos. Okay, so guys, if this is constant, won't acceleration, which is force by mass, which is E by m, yes, this will be also constant. And whenever acceleration is constant, remember, you can use kinematic equations. Yes, guys, you can use kinematic equations, and that too in x and y direction separately. Very good. Now think about it. Which direction will you prefer to apply kinematics? X direction or the y direction? Are you going to apply some kinematic equation in x or in y? The question is to figure out the time from here to here. Let's see how many of you can do this. How many of you have figured out which kinematic equation and which direction? You need to answer two things: which direction and which kinematic equation. V is u plus at, s is ut plus half at square, or v square minus u square is 2s. So guys, I feel you are going to apply it in the y direction. That will be beneficial. Why? I'll tell you. This distance is d by 2. This is midway. It's clearly mentioned. Okay. The electron is at a point midway. That means if this is d by 2. What do you think is the velocity in this direction, y direction initially? What do you think uy is equal to? Velocity in the y direction, it's 0. Yes, the velocity in the y direction is 0. And the acceleration? Well, this acceleration, believe me, is in the y direction. Yes, this acceleration is also in the y direction. In case you forgot, the field is in the y direction. So actually this is ay, which you just figured out. So which equation are you going to use? Sy is equal to uyt plus half ayt square. Just use this. What is the displacement in the y direction? Although the charge goes from here to here, see, this is where the charge is initially, this is where the charge is finally. What is the y displacement from here to here? Don't count the horizontal. Y displacement from here to here. Just check what is the y displacement. It's just d by 2. Yes, it is just d by 2 is equal to uy, the velocity in the y direction, because it was thrown horizontally, there was no component, it will be 0, plus half ay is nothing but this, so half E by m into t square. Yes, now you can see what's going to cancel. 2 and 2 will get cancelled, and therefore guys, what are you going to get? You're going to get time is equal to m into d divided by E. All right, but that's t square, right? So I need to put it under the root. So that's our final answer. How many of you got it? I want to see the chat box. Beautiful PL. Oh, PL, you made a mistake. You didn't cancel that too. Be careful, bacha. Yep, Palash, very good. Excelente, excelente. Some of you got it, some of you, yeah. Siddharth, obviously, this is going to be helpful for 2021. You guys have time. In fact, you can watch all the lectures, long-term course lectures, because this is going to cover all the topics in detail too. Very good. Amazing, says Yalini. Very good, Palash. Excellent. I'm really proud of all of you who got this answer before me, guys. Yep. Very good. Very good. By the way, all those people who always wonder, is YouTube different from our regular platform of Vedantu? Well, it's very different, guys. It looks similar, but there are a lot of features like, first of all, there is a chat feature where you can obviously chat just like you're chatting here, but there is an option where, the teacher can turn off the chat, and also simultaneously there is another chat box where you are chatting with another teacher. Yes, that teacher is not seen here. He's behind the scenes, and all of you lovely warriors, all of you lovely students are divided into small chota groups, and each group gets a separate teacher for just solving the doubts in the class. Yes, you just ask all your doubts in the Q&A box and all your doubts get answered, and there are quizzes inside the class. In every session you have the leaderboards, you have the analysis, you can see the participation, and after every class you get the data points, as in how much you did well, or did you do bad, was it good, are you improving. You can keep a track of all your performances. See, in a regular coaching, in an offline institute, you might feel you are doing good, but you never know until you actually see those data points. I have seen so many students, they get shocked when they see these results, like, oh, really, I didn't participate so well? Oh, I didn't do so well? I thought I was doing well. Then they realize, oh, I need to work on this. Oh, I need to improve my engagement. Oh, I need to work on these concepts. So all that data gets, listed after your classes. So very interesting thing, the way our platform works is very different from YouTube. Now, thank you, Hari, so much. No, we do not have Zoom classes. We do not have Google Meet classes. That's for all the newbies. We have a dedicated platform called as the Wave. So it's a unique platform. It's a platform which has a lot of patents, more than 20 patents out there. Yes, definitely, Tushar, why not? Now, let's get going to the next type of capacitor. I'm not going to waste time deriving this, but let me tell you, the derivations will be put up in the PDF, which will be shared in the Telegram group. What is important for you guys to know, that the derivation methods are the same, just like in the parallel plate capacitor, and at the end of the day in JEE you will need the formulas. So first of all, the capacitance for a cylindrical type. Now what is the meaning of cylindrical type? There is an inner cylinder, there is an outer cylinder. The inner cylinder will have some charge. Let's say like this, the inner cylinder has some charge. The outer cylinder will have the exactly opposite charge. Understand that? The outer cylinder will have exactly the opposite charge. So what will happen? There is some potential difference, inner, outer. Potential difference, charges are opposite, and that means it's like a capacitor. Fields are going from in to out. So yes, that's called as a cylindrical capacitor. Inner radius is R1, outer radius is R2. If you want to fill some masala, fill it in. This looks like a kaju roll. How many of you like kaju roll? Yeah, this is like a kaju roll. This is, yeah, you put some chocolate or you put some nice flavor inside it. And this is the length of that kaju roll, guys. Yeah, that length of that kaju roll sweet that you would have seen in the market. Okay, by the way, the formula is 2 pi epsilon naught L. Okay, so 2 pi epsilon naught L divided by log of R2 bigger radius by smaller radius. What is this ln? Ln stands for log to the base E. Everybody knows this. So this is the formula. What is L? L is the length. What is R2 and R1? Bigger and smaller radius. That's it. Very good. Palash has already written it down. Beautiful, beautiful. Yalini loves kaju roll. Vasanti, hello, welcome. Join in, bacha. Yes, yes, Venkata. I love H.C. Verma book. In fact, I have conducted micro courses on H.C. Verma's solutions, which are not there everywhere. And that's one book which has produced amazing results. All my students who have got top 100 ranks have got it only from H.C. Verma and previous year questions and the coaching material, nothing more. And Irodo maybe, yes, that's all. Yeah, so that's why I love that book. It's a very standard book, very limited errors, and it's very precise, to the point, and it gives you all the theory as well. Okay, so I have provided the derivation in the PDF. You can download it later on. Next up, spherical capacitor. So for spherical capacitor, guys, the formula is, the formula. What is a spherical capacitor? You have two shells. The inner one, let's say it has positive charge, let's say. The outer one will have negative charge. Okay, the outer one will have negative charge. So you can see there will be potential difference between the two shells. And the moment there is potential difference between two conductors, it behaves like a capacitor. It stores electrical energy. There is field between them. So the moment there is field, there is energy. It has stored some energy. The formula is 4 pi epsilon naught 1 by R1 minus 1 by R2. R1 and R2 are the inner and the outer radius. R1 and R2 are the inner and the outer radius. Yes, it's the same thing. ABCD, be careful. There is 1 by R1 minus 1 by R2. So if you take LCM, alright, it will be R2 minus R1, and this R1, R2 will also come on the top. So be little bit careful. Yes, Inayat, I will show you all the subscriptions on Wednesday. All my subscriptions will be revealed on Wednesday. I am conducting a special class to show you where you can find my subscriptions, what are the links, how you can make the best use of it, what are the courses, everything on Wednesday, guys. Yes. Yes. Okay. Errorless means, Siddharth, with no mistakes. Errorless is not the name of the book. Okay. Okay. Great. 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 Chalo, let's see how many of you can do this question. Come on. Let's see how many of you can get this. Come on, guys. The capacitance of a cylindrical capacitor can be increased by which of the following? Ankit already said C. IBCD also says C. Inayat Shahraz, the crash course is starting this Monday. In fact, it has just started today, my bad. And even if you have missed it, don't worry. You can watch the replays, and the replays are available till the end of JEE Mains. Not the end of the crash course, till the end. And you can join the crash course using the link which is there in the description box. You will see crash course link. It has 90 sessions, 20 test series, and it starts today with the best master teachers, all the 3 subjects, 11th and 12th portions completed. It's all there. Okay, chalo. Okay. Okay, cool. Let's have a look. Come on. Yep, come on, guys. What's the answer? Finally, thank you, Sheshadri Jyoti Miryala. All right, the correct answer is D. Why? Because the formula is capacitance cylindrical type. 2 pi epsilon naught L, 2 pi epsilon naught L divided by log of R2 by R1. This was the formula, 2 pi epsilon naught L R2 by R1. What do you want to do? Increase the capacitance. That means increase the length. That means decrease the denominator. Reduce the denominator, the ratio increases. How do you reduce this? What you should do? You should increase the denominator here. If you increase R1, the log value will reduce because R1 is below. So hence, increasing both the inner radius, inner cylinder radius means R1, and the length. So if you increase both of them, the capacitance will increase. You can see that that's option D. Okay, that's how you need to do this question. Next question, come on. Yep. No problem, it happens, Yalini. Let's see how many of you can do this. There is a capacitor, charge Q, inner radius is A, outer radius is B. Okay, the potential difference between them is V. Okay, now when the spherical conductor of radius B, means the outer one, if you discharge it, if you discharge the outer one, what will be the new potential difference between them? This is a very interesting question. Very interesting question. Let's see how many of you can do this. Aruna saying V or C. I'm not sure. Okay, I'm guessing she said C. ABCD also saying C. Come on, my warriors. Got it. Says Aarti. Beautiful. Come on, my warriors. Earlier, both of them were charged. The potential difference between them was V. Now, the outer one is discharged. What will be the new potential difference? Venkata, I'm working that much extra hard for you. Just imagine. So, I'm somehow managing, but I'm doing it because I want everybody to be benefited. Okay, so when I put in so much effort, when we are struggling so much, when I am sitting in day out to figure out what questions to put, what should be the flow, etc. I want you guys also to put in that much effort, guys. If I'm managing 2 channels, I'm managing the pro subscription, I'm managing the department, I'm managing other things and advertisements and so many things. Inayat, there is a separate crash course for NEET also. You can use my coupon code SHNEET for NEET. Alright, there is a NEET coupon code. You can comment below in the comment section, Inayat. I will send you the link if you want. Okay, I'll send you the link later on after the video. Pavitra, उसमें तो स्मार्ट बोर्ड से भी better है Pavitra. There is a wave platform, I understand, and it has got quiz functionality, it has leaderboard, it can do analysis. This cannot do analysis. Smartboard cannot do analysis. That can do analysis. Yep. Okay. Yes. Okay, let's have a look. Well, the correct answer is actually V only. Now you might be wondering, why is it B? Why is it V? The reason for that is there is some charge over here. Okay. Now, whatever charge might be there on the outside here, this Q could be anything, doesn't matter. The field from here to here, the field lines from here to here, they only depend on the inner charges. Yes, this field depends only on the inner charges. So even if the outer charges go, vanish, do anything, we don't bother, we don't care. Now remember that E is dV by dr in magnitude. Magnitude wise, electric field is dV by dr. So guys, if field does not change, if this does not change, obviously dV also won't change. The potential difference will remain the same between these two shells. That means if earlier it was V, now also it will be V. I hope this is clear. Is that clear? Yep. Is that understood? Yep. No, Raghunanan. No, you won't get for 1 month. Okay. Only if you get it for 12 months, then you will get it. Okay. Last type of capacitors. Chandu Rock, see bacha, for the last part, what I said, the field lines from the inner one, alright, this field is the same, right? No matter what you do, I have given you something called as the shell theorem. What is there outside doesn't matter, only the inner charges matter. So the field is same, obviously delta V will be same, and if delta V is same, the potential difference will be same, it doesn't matter. Yes Ayush, it will be sufficient. Okay, now isolated spherical capacitor. Okay, what is isolated spherical capacitor? See guys, in a normal spherical capacitor you have the inner sphere, you have the outer sphere. But imagine you just have a sphere, no outer sphere. You just have a sphere, no outer shell. It's just like saying you take that outer shell and increase its size. Okay, so in this special case you increase the size and make it infinitely large. So what have I done? I have taken the outer shell and made it infinitely large, so only one sphere is there over there. It's like the outer shell is at infinity. That's nothing but our isolated spherical capacitor. So the outer shell is like it is at infinity. Only the inner shell is there. Only that inner shell, this is that inner sphere is there, which is now called as the isolated spherical capacitor. Let's say the radius is R. Yep, very good. So Pratham, what has happened? In a normal spherical capacitor, inner shell, outer shell. If you increase the size of the outer shell, it becomes infinitely large. What is remaining? Only the inner part. So this is isolated, nothing else around it. That's why I'm calling it isolated spherical capacitor. That's all. Okay. Now, for a normal capacitor, what was the formula? 4 pi epsilon naught 1 by R1 minus 1 by R2. In this case, think about it. What is the inner radius? Inner radius is R itself. What is the outer radius? The outer shell radius. It is infinite. So it will become 1 by infinite. So don't you see, this will become 4 pi epsilon naught 1 by R minus, what is 1 by infinitely large number? Big number. Denominator, it will become 0. It will become 0. So what will happen? That R will go on the top and you'll get 4 pi epsilon naught R, which is this answer. So you should remember this formula. This is how it is. Yep. Got it? Very good. So an isolated spherical capacitor is a special case of spherical capacitor where the outer shell's radius is infinity, and that's how you get that formula. Very good. So let's solve some problems. Come on guys, I have one more question after this, and let's see how many of you can do that. Come on. Surya, you can post all your queries after the video is over in the comment section. I'll reply to all your comments, or you can ping me on my Instagram handle, which is Shreyas_Vedantu. Yep, come on. Yes, Siddharth. But we learn it very naturally, Siddharth. We don't learn it as a special topic. It's like very easily understood. Ankit saying D, Yashwant saying C. Come on, very good, Chandurok. You got it. Excellent. Come on, my warriors, figure this out. Two spherical conductors, R1 and R2, they are placed concentrically. They are connected by a wire. Then the equivalent capacitance of the system is, well, come on guys. See guys, I'll tell you what. See, when they were not connected, forget this wire was not there. So there could be a positive charge here, alright, there could be a positive charge here and an equal amount of negative charge on the inner surface. Yes, there would be an equal amount of negative charge on the inner surface. And maybe there is some other charge over here. Okay, maybe there is some other charge on the outer side. So this is some other charge. So now do you see there is field inside? That means there is a capacitor inside, okay, between these two surfaces. This is one capacitor, the red one. Oppositely charged field is there, energy is stored in the field. So that's one capacitor. And there is another capacitor outside. There is a capacitor outside. Think about it. Because of this positive charges, isn't this capacitor outside like the isolated one, the isolated capacitor, and the one which is inside is like the spherical capacitor? The spherical capacitor where two charges are there oppositely on opposite sides. An isolated one, you just have one sphere, that's it, nothing else. Don't you see that? Don't you see that? So now think about it. If you connect it with a wire, what will happen? All the red charges will go. So if it is connected, all right, if connected, what will happen? All the plus and the minus which are there will go away. It will go outside. That means all these positives will neutralize the negative. Only the green ones remain. Only green ones remain. Positive negatives will disappear. They will disappear. They will neutralize. Think about it. So the only thing that remains, what remains? Only these positives which are there outside remain. And if they remain, what is it? It's an isolated capacitor. It's an isolated capacitor. So that means, what's the capacitance? 4 pi epsilon naught R1 or R2? 4 pi epsilon naught R1 or R2? Come on guys, answer the question. The radius is R2, right? Only the outer radius. Beautiful, Yalini. Excellent, Palash. Excellent. Lot of you got, yes, lot of you got, answer as C. I was just seeing before that Surya, I think, and others have also answered as D. Beautiful. This is how you are supposed to solve this question. Excellent concept. The inner charges just go away because you are connecting a wire. The inner capacitor is destroyed. It disappears. It neutralizes. Only the outer capacitor remains. Now, regarding the last concept, yep, because there is a wire connected. Last concept, very important. A lot of questions will come on this last concept. Let's do this very quickly. Come on, my warriors. Catch up. Yes, up to speed. Force between the parallel plates. Lot of you are going to make mistakes. Trust me, because the next question is going to be very tricky on this. So observe carefully. Force between the plates. First of all, why is there force? This is positive. This is negative. Yes, this is positively charged. So the field lines go like that. This is negatively charged. So the field lines comes inwards. That's how it is. So obviously positives attract negatives. So there is some force between the plates. I want to know what's the force between them. Well. So here is what I'm going to write. The force between, alright, the force between the plates will be equal in magnitude. So it is equal to the force on any one plate. What is the magnitude of the force on any one plate? Don't you remember the formula for force and field? Force is charge into field. So just put that. It's nothing but the charge multiplied by the field. Now my question is, well, if you take this plate, okay, or this plate, the charge is Q only, so you don't have to worry about that. When I write this field, is this field because of both the plates or only one plate? Let me know in the answer. Let me know in the chat box. Is this field because of both the plates or because of only one plate? Think carefully and answer in the chat box. I'm listening, I'm reading all your chats out there. Is it because of both or is it because of one? Come on, what do you guys think? Both the plates ka field or is it because of one plate? It's exactly Mitali, I think, has answered it very quickly. No, Yalini, it is because of only one plate. You might be like, sir, why? Guys, when I have a charge and I'm finding the force because of a field, is this field created by that charge? Is the force acting on a charge because of a field, because of the field of other charges, or this charge? Obviously the other charges, right? Not because of its own field applying the force on itself. Doesn't make sense. So guys, understand this. This field is due to any one of it. Yes, due to any one of it. Understand that. Hence, the value of the field, remember the value of the field was Q by 2A epsilon naught. The net field was without this. The total field is because of both of them, but that is not going to influence any one of them. So then field due to any one of them will be exactly half of that. That means this, and hence the answer is Q square by 2A epsilon naught. This is very, very important formula and you should know how to get to this. Understood? So understand, when a field applies the force, all right, that field is never because of that charge itself, it's because of the other charges. So if you keep that in mind, you will understand why that 2 has come. But when I talk about the total field, the formula is slightly different. Okay, so I put up the derivation in the PDF, don't worry about it. Let's see how many of you can solve the last question, like I was saying, the tricky one. Ishan, you might have to watch the entire replay. This is very important, conceptual, tricky lecture. Very important formulas and concepts I have been covering throughout this class. Yep, definitely Ishan, very good. Chandurok, the next class is going to be, I think, on, if I'm not wrong, Thursday. Yep, Thursday I'm going to cover the second lecture of capacitors, and I've also put up the, the timetable in the PDF of this class. Yeah. Sir, can it be skew into sigma by 2 epsilon? Yes, Mitali, why not? Yes. Soul, there are a lot of souls who are going to write the examination next year. So it's for those souls. I'm not sure which kind of soul are you. Are you a 2021 soul? Are you a 2022 soul or 2023 soul? So, yep. Kirnar, I'm coming to Catalysis tomorrow morning, BitSat examination paper discussion. I'm even going to discuss the, mental ability part. Yes, I'm going to discuss that as well. Yeah, let's have a look. Okay, well, a lot of you are saying C. Some of you are saying B also. I'll tell you what. Okay, what is the force? Remember, force is charge into field. Charge is 1 micro. 1 microcoulomb means 1 into 10 to the power minus 6. A lot of you are going to take this value as it is. It's clearly given. It has an electric field of this much. That's wrong. Please divide it by 2. Understand why are we dividing it by 2? Because this field is because of both. Yes, this one is because of any one of it, any one of the plate. Please understand. That's why you have to divide it by 2, and hence the correct answer will be half. That means it should be 0.5 Newton. Oh, hello Umesh, welcome aboard. What is BitSat? BitSat is an examination for the BITS Pilani, BITS Goa campus, colleges. BITS is a very reputed private college and it has got very good placements, very good research, excellent crowd. In fact, sometimes better than many of the IITs as well. Keshav, without JEE, I'm not sure which other college is good. I mean, the only good colleges in India are IIITs, NITs, IITs, BitSat. Well, BitSat is the only examination which you can give apart from JEE to get into BITS. Well, this is your homework problem. You need to put up the comment in the comment section after the video ends. Let's see how many of you get this. This is your first question. And this is your second question. You can take a screenshot of this. You can rewind and get all these questions. It's not a big problem. Now, for those of you who are looking for the pro subscription and the deals out here, let me show what exactly I talk about. Oops, where is it? Please go. Okay, I'm not sure why my board is not working. Okay guys, I would have shown you where that link is, but let me tell you, these plans basically are nothing but light, classic and plus, and per month cost. This is per month. It's hardly anything. Reason is we want you to at least try it out for 1 month and gain that experience. If you don't like it, it's okay. You can not take it for the next month, but most of the students who take it for 1 month, they end up taking it for 12 months. Now, what's the difference? The difference in all of them is only in the last 2 pointers. Other things like the classes, the replays, the notes, the Tattva material, the test series, the assignments, the teachers, everything is same. Everything is same. The only thing is when you want doubts to be solved in the app, then you get that feature only in the classic version or the plus version. But if you also want a personal mentor who is going to guide you through the timetable schedule, or if you are depressed, or if you want to be motivated, if you want to somebody monitor yeah, that's when you go to the personal mentorship under the plus version. Most of the students take classic or plus. Those students who take light eventually shift to classic because they realize they want the doubts to be solved on the mobile app by taking screenshots and chatting with our doubt experts. So the link for joining this is there in the description box. There is also a link for crash course. You can check it out. So guys, I'll be seeing you tomorrow for BitSat preparation on catalysis. 9 o'clock rank booster series on this channel. 9 o'clock rank booster series on this channel. Night 7:30. I'm going to come for the 11th standard kids, and the next class of this chapter will be on Thursday, guys. Yep, it's going to be on Thursday. Yes, okay. So guys, our next topic is going to be about series, parallel capacitances and all of that, energy stored in capacitors, and so many different things, heat developed in charging, discharging and all those kind of stuff. So see you guys again on Thursday. Remember, all my lectures are at 7:30 or on Tuesdays and Thursdays at in the morning at 9 o'clock. So guys, it's been a lovely evening. Thank you for tuning in. Hasta la vista. This was Shreyas here, your master teacher for physics at Vedantu.